Hi there, this is Matt Heffernan. Welcome back to my channel. This is episode 24 of Slithy Vlogs, and today we are going to take this little time for a little informal chat to talk about my newest game. And I know I've have a lot of games on the back burner right now, but this one was a pretty easy one to accomplish. And I think the really interesting thing is that this is based on one of the biggest viral games of this year, but I figured it is simple enough that we can actually make this work for the good old Commodore 64, which, hey, it just had its birthday, 40 years old. In fact, in this month, in early January, actually, of 1982, the very first public presentation of the Commodore 64 prototype was demonstrated at the Consumer Electronics Show, and it was, of course, a big sensation immediately. And, of course, it was far beyond the capabilities of any of these other 8-bit machines that had come out, and really, if any of the machines, even like the early 16-bit machines like the IBM PC, were not really able to do the same kinds of graphics and sound that this machine could do. And the really amazing thing is once it came out in August, it was only $595, which was still really, really inexpensive, especially in the North American market. And what people got was really the best platform for gaming that was available at the time. And it was, of course, obviously a huge success. It's the best-selling computer of all time, and all the way through 1994, when it was finally discontinued, Commodore sold over 12 million. Some people say possibly as many as 30 million, although that number is a little suspicious, but it's definitely way more than any other computer ever sold. So we're going to take a look at today at why this is so impressive, not just beyond the capabilities of the machine, but why specifically was this machine such a good platform for doing development on? Well, it really comes down to the kernel, the Commodore Business Machines kernel. So, of course, that's the official name of the Commodore company. It was Commodore Business Machines, and really their first computer, before they did calculators, but their first proper computer was the PET. And the personal electronic transactor, to be specific. And what it had was, of course, a 6502 for its CPU. So it was one of the very first microcomputers on the market that was intended for both home and business use. It was not just a kit computer, it was a fully commercial product. And it had a built-in monitor, and it had the very first version of the kernel, and a lot of the things that later Commodore models had were already in there, in that PET. But of course, it was still very rudimentary, beeping sounds, and no color graphics. It was all just monochrome, but pretty high resolution. You could have 40 or 80 column text modes, and it was really a fairly useful computer for productivity, and continued to go on even after Commodore started creating stuff like the VIC-20, their first color computer. So the VIC-20 was named, of course, after the original VIC chip, which supplied both the audio and the video for the VIC-20. And that video was fairly low resolution, especially compared to the PET, but it did have that added benefit of the color and the ability to have synthesized sound, something more than just little beeps. Wasn't, ground shaking compared to stuff that came later, but it was a really solid computer, and it had some of that backward compatibility to the PET by taking advantage of that same kernel, using specifically that kernel's API. All of the jump tables that are in it, it has the same routines in the kernel ROM that do effectively the same things on the VIC-20 as they did on the PET. And they kept us going, of course, with the Commodore 64. Still had the same kernel. It had to have some additional different kinds of things implemented within the code, but the kernel interface itself stayed the same. And so you were able to have a built-in BASIC, just like in all the other machines. And that BASIC interpreter has the ability to edit anything that's on the screen, to move the cursor around, to keep track of that cursor position, and of course, starting with the VIC-20, the ability to color the text that starts getting printed out at that cursor. So really cool stuff coming out from Commodore, but of course also you had all of these bitmap modes, and then once you start getting into how to deal with the sound and more advanced graphics beyond text modes, that's where a lot of the compatibility starts breaking down, because you're not using the kernel at that point, you're really more directly accessing the hardware. But by just sticking to those kernel routines, it gives you that compatibility, because we're still talking about the same CPU in each case. We're talking about variants of the 6502, the same instruction set, and then these same ROM routine locations, the same behaviors, and those were used in even later machines in the Commodore 8-bit line, including the Commodore 16, which was a low end. This was Commodore's attempt to try to really retake that lower end of the market that, say, Texas Instruments and overseas, where you'd have Sinclair creating these really low-cost machines. And Commodore said, well, you don't have to be quite as fancy as a Commodore 64. You can make a pretty decent gaming machine with cheaper hardware. And that's what the Commodore 16 was intended to do. But it didn't do too well, and neither did its successor, the Commodore Plus 4. But the Commodore Plus 4 is pretty much backward compatible with the Commodore 16, so it has all the same hardware, the same sort of capabilities in it, just mostly a different form factor. And they still use the kernel, so all those same kernel routines at the same addresses are still accessible from there. But then again, like between the Commodore 64 and the VIC-20, you have to eventually get down to, closer to the hardware, and you can't just depend on the kernel, especially when you're creating things like games. So you don't have that same sort of compatibility. But still, taking advantage of that kernel continued to evolve into the Commodore 128, where not only did you have that legacy 6502 system that did have backward compatibility to the Commodore 64, it also had within it basically a second computer. It had a Z80 in there as well, so it could run things like CPM and other more productivity-based software, but also just to have a whole lot more capability. And so if you were going to create a sort of a text-based application, you're still using that kernel, and you have additional things added to that kernel to do some more interesting stuff with the Z80 and so forth. But you'd still have a lot of compatibility, even going back to the PET of being able to just do these same kinds of kernel calls, as long as you're sticking to that 6502 side of it. And nowadays, of course, we have new versions of these Commodore machines, like the Mega 65, which is based on the Commodore 65, which was a prototype that didn't really go anywhere. They never made it to market. And like a lot of these other machines, it was trying to go back and have backward compatibility with the Commodore 64, but then have additional features like a 3.5-inch floppy drive, for instance. And of course, now the Mega 65 is a resurrection of that Commodore 65 with a bunch of new features and an FPGA-based 6502 that is going to let you do all sorts of fancier stuff at a faster speed and better graphics modes and so on. But it still uses that kernel, and those kernel calls can still be done as they can in the Commander X16, which, of course, if you've been watching my videos, you've seen a lot of stuff that I've done for that computer, which unfortunately is not out yet because of a lot of these global supply chain issues that we're dealing with. But the emulator still works, and we're going to see how we can make a game for Commodore machines that could run on, at least for now, the Commodore 64 and the Commander X16. So let's take a look at now PETSCI. PETSCI, of course, is the character set for all of these Commodore kernels. And because in a lot of cases, you don't need to have proper bitmap graphics in order to do a lot of simple things, including pretty simple games. And you could take advantage of this PETSCI character set and be able to print out all these codes, not just for characters, but as you can see, there are different control codes too, like for changing the color of the text you're putting out, going to reverse a video, moving the cursor around. All of these different things you can do with the kernel by printing out these different PETSCI character codes. So it really lets you not just create something that's visually interesting, but has that compatibility so that when you port these software applications and games and whatever from one Commodore 8-bit machine to another or to one of these newer platforms, you don't have to do a whole lot of specific code for that as long as you really try to stick to that kernel as much as you can. So let's see how we can take this to now recreate this viral game in an old school 8-bit environment. So let's take a look here first at what we're trying to do. We have a word list. These are 5-letter words. And this list here is over 2,500 entries long, and it has common English words, or at least it should in theory. We're still working on that. I have folks in the Commander X16 community helping me curate this list and refine it. But basically, this program, this game, will select one of these 5-letter words, and then you have to guess it, and you get 6 guesses to do it. And it will let you know if any of the letters are in the right place or at least exist in the word that you're trying to figure out, but you maybe have that letter in the wrong place. And we'll see how that works here very soon. So what I do before I even get into the 8-bit machines, back here in the modern world, I can take this list and I can create a C program that will convert that word list into a more searchable table on an 8-bit machine. And specifically for the Commodore kernel, you want to be able to have a file header on that so it knows where to load it by default. And then also we can do things to make it easier to search, like putting in a lookup table. So here I can take the first 2 letters of each word, each 2-letter combination, and it lets you jump ahead to that part in the list. Or if there is a null pointer in that part of the lookup table, then you know that, well, that 2-letter combination doesn't exist. Like ZZ Top is not a common word, it's a proper name. So if you go to the ZZ part of the lookup table, that will be null, because we don't have any actual ZZ words in there, for instance. So that's what we do first, is use this the modern system to do a bit of pre-processing on the word list, because that's not going to change during the execution of our program. So we can leverage modern systems that can deal with this data a lot more easily. And then we get into the kernel. So the way we access the kernel is with this include file, and this comes with CC65. And if you go back to GitHub, and the link to this repo is going to be down there in the description, you can see here all the code. It's all free and open source, and the game is called Word Slide. And here's what it looks like on the Commodore 64. You're guessing the words, and there's those yellow highlighted letters are the right letter in the wrong place, and the green letters are the right letter in the right place. And it shows you how to build it. So you're going to need GCC to build that word table constructor, and then CC65 for the actual 6502 code that we're going to be building. So let's take a closer look here at the kernel. Now we can see there are conditional preprocessor statements in here. So if we are dealing with a Commodore X16 program, we have all of these new methods here in the kernel. And if it's a C128, there's new ones for that. And here's a bunch of kernel routines that were introduced for the C128 that are also included in the Commodore X16 kernel. So you can see a lot of the history of how the kernel has evolved. And here we have others that are for the Commodore 64, the 128, the 16, the X16, but not the VIC-20. But here, hey, it's all of these machines here for the VIC-20, and here's some stuff that's even available for these old pets like the 510 and the 610. They have all of these same ones, but the ones we're going to really care about are like carout, and that's what we use to print out these PETSCII codes. And all the control codes, changing the color and printing out all the characters. That's mainly what we're going to be using is carout. So, and you can see here, available on all platforms, including the PET. And also the plot, because that helps us move our cursor. And as you can see, even these old PET machines let you use plot, as do the VIC-20, the Commodore 64, the 128, the Commodore 16, and the CX16, the Commodore X16. So we have this pretty rudimentary but very powerful toolbox, because we're not just having these common kernel methods at the same address and the same behavior. We also have that same character set across all these different systems. So in our code, it starts the same, as the Commodore X16, Commodore 64, most of these Commodore machines. You need to set it up the same way, set up these required segments, and then you can have a jump right there at the beginning of the code segment to where your code actually starts. And then in between, you can have your data. And here I include that kernel, the header file, and then I have a bunch of text, including the initial loading that you'll see, and then that game board that we saw there on that screen cap that's on GitHub. And it sets that up initially, all this other data that's in there, and finally we get to the code here at start. And as you can see, there's only a bit here in the beginning, like for instance, setting the background to black. There's no way to do that strictly with the kernel on the older machines. The Commodore X16, however, you can use the kernel to do that. So you can set the foreground color to black. So this is something that you can do on going back to the VIC-20. But what you don't have is this newer routine, or rather this new control code that triggers a kernel routine. That at number 1. So if you just printed out the PETSCII code 1 on these old machines, it would be ignored. But for the Commodore X16, it swaps the background and the foreground, so we're able to do that. And of course, Commodore X16 is initially in this 80-column mode, so we want to get it down to the 40-column mode so it looks a little more Commodore 64-ish. But for the Commodore 64, all we got to do is poke a 0 to this magic address. And that's going to set our background color, and 0 stands for black, just as it did on the VIC-20, but the VIC-20 had a different address. So we still have to do a few things differently on these different platforms. But once we get past that, we do have a bit more code that's specific, like how we do random numbers is different. For the Commodore X16, we have special kernel method for generating these random numbers, but for the Commodore 64, that didn't exist. But what we did have was something really even better, which was the SID chip. And the SID chip had a noise generator, which you could then peek at to get sort of a current level value, and that was effectively very random. So especially once you seeded it with the real-time clock, which then we can do here, you know, I don't have the VIC-20 stuff all fully implemented yet. I'm going to have to figure out how to do random number generation on the VIC-20. That's going to be interesting. But anyway, here we can see I'm just reading from the real-time clock, and I'm using that to help seed the random number generation, all the same on all the platforms. And then again, like here, once we actually load that word table into memory, and of course, as you could probably guess, a word table of that size is going to require a memory upgrade for the VIC-20, but the goal is that a commonly available 16K memory upgrade that you could get for the VIC-20 that have everything fit right in that, and I don't think we'll have a problem accomplishing that. So, I mean, right now it stands with the word table and the code. It is about 14 to 15K, so I think we're in good shape. I don't intend to add that many more words to it. But you can see here all the kernel methods for loading that. And then eventually we get through all this stuff, and you'll see a lot of stuff where we are like here printing that screen text out with care out. And in that screen text is, you'll notice here, not just text, again with all lowercase, because that's what you have to do with CC65. It sort of mimics key presses, and so you wouldn't want to have shifted letters, because that will get you, when you're in the graphics PETSCI mode, it will get you graphics characters rather than capital letters. What you do get is with an unshifted press of a letter key is a capital letter already. It's not going to be lowercase. So it'll still work out in that case, but then we have a bunch of other things that are mixtures of control codes and graphic characters that we can't really put into the assembly language file like we can with the text. So we have to call out the actual PETSCI codes within there. But it's simple enough to do, and when you have a good reference for that, it comes together pretty quickly. So that's the code, and I'm not going to go into super detail. Again, this is all available on GitHub. You can go ahead and do the whole GitHub thing, copy this URL and do a clone of it, or you could do a fork of it if you want to start going your own way or start contributing to it. You can, of course, post issues. Somebody's already posted an issue. Isn't that nice? And, of course, if you do have a fork, you can submit pull requests like, hey, you've added some words or some new features to the program. Go ahead and do a pull request, and we'll get it in there. But right now, let's take a look at the actual game. So here in the Vice emulator, we can load up the program that we built. So the build script in there will generate a executable called WSC64. And what I've done here in Vice, which is what I would recommend, is to map the workspace directory into your virtual disk device. And of course, by default, that would be device 8. So we want to do a load WSC64, 8. And so that'll load up just the program file. And so you can see that that's pretty quick because it's a pretty short program. There's not a lot of code to it because this is a pretty simple game. And then we run it, and then we'll see it's already done that, switch the background to black, but the loading prompt comes up while it's going through the process of loading that word list. And the word list is like over 13K. And even with a virtual floppy in emulation, it still takes some time because it's really trying to emulate all that. But you can see that's how long it takes. Your mileage may vary when you have a real physical floppy drive, but it should still come up within a reasonable amount of time. But then here you are. Here's word slide. And you just have a blank slate. It could be any of those 2,500 words, and that word has already been selected thanks to that SID-based random number generation. So we try a word like games. Ah, well, now I can see. Like, I don't even know what the letter, what the letters are going to be. I don't know what the word is because this is completely random. And so, by nothing getting highlighted when I typed in games, and you notice all 5 of those letters have been removed from this keyboard visualization down here. And that lets me know that none of those letters are in the actual result. Now, if I were to put in a word that doesn't exist, like I start spelling slithy without the Y, it's like, no, slit's not a word. You can't do that. So every guess, you can't just guess letters that you think might be in there as a throwaway guess. You have to guess actual words that are in that word list. So let's try something like party. Ah, now I can see that this word has an R and a T in it, but they're not in either of those places. The T and the R might be switched over, or they could be in one of those other 3 places. So let's see, what could it be? So we we already had eliminated the A, but now we've also eliminated the P and the Y from the word. So what could it be? Let's say if it starts with TR, it could be a trick. Is it a trick? No, it's not a trick. In fact, we've eliminated the C and the K. We know we have the R now in the right position, but the T and the I are wrong. And you can see again in the keyboard visualization down below, the R is now color green because now you have at this point guessed the proper position for R, and the T and the I you've discovered are in the word, but you don't know where they're supposed to be yet. So it definitely doesn't start with a T. Where could that T be, and where could the I be? Maybe it starts with another letter. What could come before the R? Maybe an F. Let's see, FR. It's not going to be an I. Maybe a U. Could it be fruit? Fruit would fit. Fruit would be a valid guess, and it was. There we go. And congratulations to me, I won. And then it asked me if I want to play again. And I got it only 4 guesses. That's not too bad. So let's just try it again. So something I like to use as a first guess is stare. Sometimes I'll do rates just to get those 5 letters. It's not S, but let me just try to kind of throw this game away. This game's, oh, look, I still kind of figured out that it does end with S. So yeah, in fact, different conjugations of verbs are allowed. So just as plurals of nouns are allowed. So sometimes you'll get those things that are 4-letter words, but then they're conjugated or pluralized to have an S at the end. Still perfectly good words that are in here. Let me just do some more things like, hey, retro. No, it's not that. But again, like something like, oh, I think Sonos is a word. No, sorry, it's not a word. Well, maybe I want to add it. That's something you can always suggest. But definitely if it is completely a common English word, then I will definitely add it to the list. But if what comes up as a secret word at the end is a word that you've never heard of, then chances are maybe a lot of other people haven't heard it too. And that's maybe a word that should be removed from the list because it would just be unfair to make people guess words that are so super obscure. So let's keep going here. What else could it be? Is it roses? Oh, I got the O and the S in the right spot. Let's see. Again, this isn't Spanish. Pollo is not going to work. Hotel. How about that? It's not giving me. There's no L in it. There's no H in it. I'm just kind of throwing away things here anyway. I kind of want to lose. Let's see what happens. Pour, P-O-U-R-S. How about that? No. Oh, see, now you saw there. Pores, P-O-U-R-S, it says it's not a word. That's definitely a word. That's something I'm going to add. So since I did that right now, it's easy enough for me to add it. I can just put it right in the word list. So I got to keep it in alphabetical order for everything to work. And you can see, indeed, pores is not there. So I'll add pores to the word list, and so the next time I rebuild, I'll be able to use pores as a guess, and in fact, it may even come up as the secret word. So let me just say hours. I know that's not going to be correct because H is already eliminated. And I said, nah, the word was boons. Oh, that's still a perfectly cromulent word, boons. It's the plural of boon, which a bit archaic, but you know what? I'm good with keeping it. But what do you think? Let me know. So anyway, that's how it works in the Commodore 64. You can always say, I'm done playing, and say no, and then it'll just drop you right back to basic. Super easy. And on the Commodore, or the Commodore 64, it works that way as well as it does on the Commander X16. So for the Commander X16, I have another WS, but this time X16.prg. And I don't have to do a .8 because this is assuming the SD card. But here in the emulator, it can still map a host directory to a virtual SD card, but then it actually loads up pretty faster because instead of having to use the kernel to actually load it, just dumps that right into RAM as fast as possible, thanks to these modern machines. So now when I do a run, it's instantaneous. It wouldn't be quite instantaneous on an SD card. It would be faster than a floppy, but it would still take an appreciable amount of time. But otherwise, on the Commander X16, the game works exactly the same. It looks exactly the same. We don't have the concept of a screen border so much on the Commander X16. But I can do the same kind of thing, like use rates as my first guess and say, no, how about learn? No, all right. Anyway, I'm not going to get too deep into this on the Commander X16. Suffice it to say, it works the same. And then if you don't want to actually do it on the emulator that you have to install and then build everything, what you can do is go to the Commander X16 website, and I'll be linking this also down in the description. You can just download the actual executables to run on your emulator, or if you don't even want to install the emulator itself, you can click this Try It Now button, and it will bring it up in the web-based emulator of the Commander X16. So now this viral web game becomes a new web game, but more 8-bit. It's a Petsky 8-bit beautiful thing that is not something you can just play once a day. You can play it as much as you want and build your skills. And if you really want to get advanced, you can contribute to this project. It is a free and open source project. You can do the pull request, you can submit issues, and you can have a real say in which words are going to be added, which are taken out, and then maybe letting this game evolve and become a little more graphically sophisticated. Like on the Commodore 64, we can make it look a lot nicer, and we can make it look a whole lot nicer on the Commander X16 or say the Mega 65. You could really make some really nice looking graphics on those machines. But for right now, trying to make it so that it hits that lowest common denominator of color Commodore 8-bits, so that we'll have this work on the VIC-20. We're keeping the width of these characters to 20, so that when we have the VIC-20 version, that 20 by 25 display will look reasonably good. And then, of course, also the being able to run it on the Commodore 16 and the Plus4 and so on. So that's it. That's all I've got to show you for now. So I hope you go and check out that game. Try it on the Commander X16. Start putting in all sorts of things that may not work. And don't put in common or proper names. It's not going to work. Sorry, folks that may want to do that. It's not going to happen. How about shoes? Is it shoes? Oh, it's not shoes. It was sheep. You gotta wake up. Wake up to that. All right, no, we're not going to play again. What we are going to do is load up the best part of the video is, of course, the Patreon screen. And a big thanks to all the folks that you see here. They're getting to see this video before the general public, and getting to see it ad-free, and also really getting to contribute not just to my open source projects, which anybody can do, but really contribute to the content of this channel, and really forming a community around retro development, and creating the best possible content to evangelize this whole 8-bit programming thing. Anybody can make a web app. There's a million different ways of doing that, but having the resources to be able to create 8-bit games that run on multitudes of different machines, that's something you're not going to get everywhere. So if that's something that you want to help contribute to, you can join on Patreon, but you don't have to give me a single dime. You can just like this video, comment on it, let me know what you think, and then really helpful is to subscribe, of course, so that then when I have more updates on this game or more tutorial videos to show you how to build games like this, you'll know when those come out, especially if you click that bell, and then you'll get notified immediately when those videos go public. All right? Well, I thank you for watching, and I hope to see you again really soon. Bye-bye.